Hello everyone. Today we will be exploring the concept of simple harmonic motion. Before we dive into the details, let's begin with a brief overview of simple harmonic motion. Simple harmonic motion refers to the back and forth motion exhibited by a system. In this, the restoring force acting on it is directly proportional to its displacement, but opposite in direction. To grasp the concept of restoring force, imagine a mass attached to a spring. When the mass is displaced from its equilibrium position, a force is exerted by the spring to bring the mass back to its original position. This force is known as the restoring force. When the mass is in its equilibrium position, it experiences no net force, and the spring is neither stretched nor compressed. However, if we displace the mass to the right or left from this equilibrium position, a restoring force will come into play. Hooke's law states that the magnitude of the restoring force is directly proportional to the displacement from the equilibrium position. Mathematically, we can express this as F is equal to minus kx, where F represents the restoring force, k is the spring constant, and x denotes the displacement. The negative sign in the equation signifies that the restoring force always acts in the opposite direction of the displacement. If the mass is displaced to the right, the restoring force will act to the left and vice versa. Derivation of SHM equation. We know that restoring force F is equal to minus kx. From Newton's second law of motion, we can write F is equal to mass into acceleration. Now, just bring this mass to the right-hand side. We can write A is equal to minus k by m into x. We also know that omega square is equal to k by m. Substitute this, we get A is equal to minus omega square x. Now, this acceleration can be written as dv by dt. Bring this to the left-hand side. Now multiply and divide by dx to this term. Here, dx by dt is nothing but velocity. Therefore, we can write v dv by dx plus omega square x is equal to 0. Now just multiply dx on both sides. We get this. Just bring this term to the right-hand side. Integrate both the sides. We get v square by 2 equals to minus omega square x square by 2 plus constant c. At an extreme position, v is equal to 0. And x is equal to maximum displacement, that is amplitude. Substituting these values in the above equation, we will get c equal to half omega square a square. Substitute c in this equation, we get this. Now, we can cancel 2 and take omega square as a common on the right-hand side. Now just apply root on both sides, we get this. We also know that velocity v can be written as dx by dt. Just bring this dt to the right-hand side and root of a square minus x square to the left-hand side. Integrate both sides. To integrate the right-hand side, we need to use a method of substitution. Let's do it. Consider x is equal to a sine theta. Differentiate with respect to theta. We get dx by d theta is equal to a cos theta. Bring this theta to our HS, we get dx is equal to a cos theta d theta. Now just substitute x and dx in the above equation, we get integration of a cos theta d theta by root of a square minus a square sine squared theta. Integration of omega dt is omega into t plus phi, where phi is an integration constant. Just take a square as common and take it out of the root, we get integration of a cos theta d theta by a into a root of 1 minus sine squared theta. A gets cancelled, 1 minus sine squared theta can be written as cos squared theta. Take this cos squared theta outside the root and cancel cos theta cos theta. Integration of d theta can be written as theta. Now, here we have considered x is equal to a sine theta. From this, theta can be written as sine inverse of x by a. Therefore, sine inverse of x by a is equal to omega t plus phi. Bring this sine inverse to the right-hand side, we get x by a is equal to sine omega t plus phi. Further, we get x is equal to a sine omega t plus phi. This is the displacement derivation of simple harmonic motion. I hope you understood. Thank you for watching. If you have any doubts, please leave a comment below.